So where were we? Okay, so here we have register range that's called here invalidate TLV, reserve range, allocate range, free range. Okay. So I guess I'm going to get started on reserve or register range. And how do we go about this? So if args type, and we get that as type. So otherwise, this would mean that we register a new free range. Otherwise here, register a new reserved range of type. Okay, so let's think about this now. Let's do the free ranges first, because they are fairly simple, since we have only one type of free range. So let's do const range list free, let's call it free ranges, is self.free ranges. Just get that out. And we want to basically try to find if we have any range in there that would actually either intersect with the range we are trying to add or contain it. So basically there are three cases here that I can see, I can think of at this moment. So we could have, so start of range 1 and let's call this and of range 1. And so let me just do this. The first case would be that we have the start of range 2 somewhere here and the end of range 2 somewhere here. That means that there's overlap on the end of range 1 and start of range 2. So here range 2 is the range that we are trying to add, and range 1 is the range that already exists in our free ranges list. The second case would be start 2 somewhere there and end 2 somewhere here. So they overlap on the start. And the third case that we need to handle would be something like start 2 and 2 would be totally inside our range. In this case, we just need to do nothing. So this is the simplest case, and I think we should handle that first. And then these two here would be a matter of merging the two ranges. And I believe there are special cases for every one of these. So this one, the special case would be S1, E1, and then S2, E2. So basically the end and the start are the same point. So that means that this range here just gets added to this one. Same goes here. So this one have S2, E2, and S1, E1. That means that we just merge the two of them. But let's first think about this case here. So we'd like to know in which case we are. And I believe one way to do that is, so here we have 1, 2, and 2, 1. Here we have 1, 2, 1, 2. And here we have 2, 1, 2, 1. So that actually would be a good way to indicate where we are. So let's compute start diff. This would be So range dot start. So range dot start minus start. Yes, so we do have start here. And const and diff would be range dot and minus and, but we need to compute and, so const and would be start plus length. Right. So in the case where this one here is positive, we should be somewhere here. So this would be this case here, because that means that this start here of range 1, so S1 is larger than start we have been given. So that would be this case here. So start diff positive would be here. This would definitely be start diff negative, and so would this. And I guess this one here also has another case that we haven't thought about, and that would be, well, S2, and then contains the range that already exists. Yeah, something like this. So this one here would also have start diff be positive. Actually, let me just do this just for now. And now this would actually have start diff be negative also. Right, so now what about the ands? So we do and 1 minus and 2. So that means that this one here has and diff positive. This one here has and diff negative. This one has and diff so negative also, and diff less than 0, and oops, and this one has and diff so E1 minus E2, this one would be positive. Right, so are there any cases that overlap? No. So all the cases are different. So these are all the 4 combinations that we can get from these 2 inputs. Okay, cool. So there's another thing we need to check. So basically we need to do the checks only and only if. So start. Let's think about that. Yeah, so only if start, so S1 minus S2, or rather if S2 is between E1 and S1, or S1 and 2 and 1. Yeah, because if either S2 or E1 is not within this range here, that means that we have 2 totally separate ranges that we need to work with. Yeah, okay, that makes sense, I think. Right, so now we need to basically loop until we find one range. So loop all the 3 ranges until we find one range that satisfies this, and then use that range to basically check which case we are in and do whatever is needed for that case. Right, so let's do that. So I'm going to need a variable which would contain the free ranges dot iter, I think we've called that, yep. And while, oops, actually, let's give it a name. While iter.next, we capture that as, let's call that range. And here we can actually take these. Before we do that, let's do var current range, and this would be, of course, a let's call it null for now, and let's do if range dot so item, and let's do const range equals item dot range. So if range dot start is less than, so if range dot start is less than start, and range dot end, I don't know if we have range dot end, but I think we should do something like const range and is range dot start plus range dot length. Okay, we'll get there. So this would be range and is over or equal. Actually, all of them should be inclusive. So if range and is above the start, right? Or, so that's the first check. And we can do that. And then here we can do the same for if range dot start is lower or equal to, and we've computed and, of course, and range and is over or equal and in this case here we set current range to be range, right? And so now we can get rid of all of these. There we go. Okay, so now that we have our current range here, well, actually, there's cases where we don't have a current range. So if current range, we get that as, let's call it CR for now. Otherwise, so this case here, let me just do something like this. And in this case here, we just do free ranges, append. And here we need to actually, we need to allocate a result. Yeah, so we need to allocate it inside here. Actually, I'm just going to go ahead and steal that from somewhere. I know we have the exact same code we are going to try to write somewhere here. So we're just going to steal that. Where did I put that? Yeah, there we go. This is what we are looking for. Right, so this should be here. And now that we have that, now we actually discovered that we need to get an allocator. So allocator. So alloc is alloc, and this here needs to have alloc, which is an allocator, and we need to declare const allocator cater is stud mem allocator. Right, and that means that now we need to go over here. This also takes alloc to be allocator, and at some point here we are going to call init. I believe. Yep, that's it, with a lock, of course. Okay, that looks pretty good. Now, let's see where we go from here. So this one here would be item, and this here needs to be vert memory. Is that it? Yep. Let's call this sure, free range item, and let's do same here. Free range item. So now we need range, and we actually don't need that anymore. We can do this, and we can do self dot lock dot whatever we want. And here we are going to create const range to be yeah, actually we can create range here directly. Don't need any of that. So start, that would be start, and length would be length, and I guess that's pretty much it. So vert mem range that has start and length. Start is a virtual array, so maybe do bitcast. Yeah, sure. And okay, so we've renamed that, so free range item. All right, cool. So that's pretty much it for the case where we just add a new range, I think. We'll see. We'll see. So now that we have our range here, so we need to check by computing our two differences. So I've actually lost that code, but let's write that again. So start diff would be current range dot start minus start const, and diff would be diff current range dot so current range dot start plus current range dot length minus and, I believe. Okay, so if start diff is above, so hold on, let me think about this for 1 second. So if either of them is, so let me just do this. Special case is, what's the special case here? So and diff is equal to length. Yeah. And so and diff is equal to length here. And this one here is special case is start diff is equal to, no, actually and diff also is, should be equal to minus length of the second. I'm not sure we are going to need a check for that case in particular, but for now let's see. What are the easy cases? So this one here and this one here. These are the easy cases, and those cases are where the signs of start and diff, so start and diffs are different. Okay, so maybe we are going to try to manage those together. So let's do start times and. So that would basically give us which sign. If that product is negative, that means that the signs were different. So if that's less than 0, so I'm thinking about special cases here. There is a special case. If start diff is equal to 0, that means that both of those have the same start. If start diff and undiff is equal to 0, it means that we have pretty much the same range that we are trying to add. If undiff is equal to 0 but not start diff, that means that one range is within the other, but they share the endpoint. But I think those cases should be handled easily in the in the rest of this implementation we are going to do. Right, so here the signs are different, so we should handle these two cases here. Otherwise, we have the cases where one range overlaps the other one. So we are going to need to check what the start is, what the end is, and we just need to extend one range to be within the other one. Yeah, actually, I'm thinking about this the wrong way, I feel like. Because we have found the range that contains this one. So all we need to do is get the lowest of the starts, get the highest of the ends, and just merge them. Yeah, so I'm not sure why I'm doing all of this. I think we could just do const new start would be at min, so cr.start and start, sure. Const new and would be at max of cr.start plus length, and yeah, well, no. Yeah, we are still going to need to do a few things. So this only works if we are working within, or rather in this case here. No, it only works within this case here. Yeah, actually that does work, I feel like. So let's keep that on hand for now. I'm just going to remove that, and let's create a, rather let's change the range. So let's set start to be new start, and let's set the length to be new and minus new start. Right, so let's comment those out and see where we go from here. And let me just, I'm not going to log that yet. I'm going to actually go ahead somewhere over here and do log dot, rather let's get an iterator over that list. So what do we call that? So vmm dot free ranges, I believe, and then while iter.next, get that as range, as item, and actually let me just go ahead and copy what that was somewhere here. Print, there we go. I'm going to do this. Okay. So this one would be print free ranges. What is the problem here? Oh, needs a self, of course. So self, just a pointer to this, and this would need to have self.vmm. Right, and we don't need that. And let's think about this again. We should have, we'll see why it doesn't compile, because it will not. But for now, let's do try vmem.init with heap permanent allocator as, yeah, sure. And let's do vmem.print free ranges. Of course, we need to define vmem, so const vmem is import memory vmem.zig. Right, and we'll go here and we'll just remove that for now. And actually, I'll just do here register range, and I'll register, for example, from 0x0 to, let's do a range of size. 10 pages, yeah. And that's pretty much all there is to it. We actually need still to give it that, or so let's see here. Yeah, okay, that looks good enough. So let's see what are the issues. Back in integer is U64, but bit size 64 has a total size of 0. Well, that's a new one. So 93. Yeah, wrong. What? Where's that coming from? Back in integer is 0, but struct fields have a total of 0 size. Oh, right. Okay. So I've copied that, but I've never fully copied it. So I think it's here under address space, and this is what I wanted to call the address. Right. Okay. It's my bad. Type enum literal is not a function. Of course it's not, because we need to actually give it a type. So this one here would be virtual memory manager, whatever that is. And now we are going to get started. So overflow of integer, so the same thing we had before. We just need to, first of all, do the multiplication and then do the negation. So cast is called qualifier, that's right, and that means that we have, okay, so we cannot declare vmm as const. Okay, so expected error union type found memory.vmem. Oh yes, of course, because now this can error. And because that can error, this can error also. That's already the case. So that should be okay now. You cannot bitcast from comptime int 146. You cannot bitcast from comptime int. Okay, well. Let's let's create a const 0 u64 is 0. Sure. So 0, and this will also be 0. No field type, or no field name type in that. Why? No field name type. Oh, okay, so it's called just type. Okay. No member called QuickMap PTE. Oh, right. My bad. So this one needs to have quick map. You don't need that. Add quick map PT. Okay, let's see here. Variable of type must be comp time or const, so current range. Current range. Okay, so this one would be a virtual vert mem range, I believe. Last item. No, just range. Just range. Yes, that should be that. And of course, it should be null if it's to have null. Incompatible types, v address and u64, of course. So that's pretty much this, and that should just be bitcast. I think we can do that. Yeah, so that's u64. Oh, I guess, okay, so this is, so that, and then we do that. And then that makes this redundant. We can get rid of that. So here we should also extract, so const current start is as u64 bitcast CR start. And that means that this one here would be current start, and this one here would also be current start. Right. Do we have something else here? We should have. Yeah, so let's get range start extracted out. So as u64 bitcast range.start, and that means that all of this here should be range start. So will all of this here, and all of this here. Yep, start. And obviously this would need to be bitcast in. And that means that this should be okay. Okay, let's see. Almost there. Cannot assign to constants, that's fine, because we have this. Actually, we should. That's not where I want to make the change. I want to make the change somewhere here. And that should be that, and this item here should be taken by reference, and then this should be that. Type const does not support field access. Where is this defined as const? Okay, actually, never mind. So variable range. It's never muted, but Okay. Does not support field access. Oh, because the, right, okay. So this one itself should not be, type pointer to const pointer. Pointer to const pointer. Actually, item is, okay, so never mind. This is good. Item is already a pointer, actually. So expect a pointer to WLX list of whatever that is, and actually found a constant. Right. So, yeah. No. What was the problem? Expected a list, doubly linked list. Right, okay, so that's this problem here. So this one needs to be a variable. Okay, so this one here is just the error thingy that's ignored, so we can do this, add try, and that should make it happy. Value of type memory.vmem is ignored. Is it? Should we do this? Oops. Something like this? No, actually, no, never mind. Never mind that. I'm actually going to do var or const. I guess kernel vmem. Sure, is this. And that means that here we can do kernel vmem to be print ranges. Const, this, oh, it's const qualifier, of course. This does not really need to have a pointer, just needs a const pointer to that. Okay, so incompatible types, vmem, vaddress, and u64. Again, that's 115. Right, so const start address is as u64 bitcast of self.start. That means that here we're going to actually change that argument to start address, oops, and change this to start address. Okay, finally. And now it should be crashing. And it does. Right, page fault. That's great. Page faulting on so somewhere within our virtual range thing here. So let's first do log.info. Got current page map. Let's just print something like this and do root. Okay. Got current page map at whatever that is. Let's see here. Do we have any idea where our page map is? So BDE2 something. BDE2000. That looks okay. Actually, it does look okay. Do we have CR2 here? Oh wait, CR3, sorry, yeah. So CR3. We do have BDE 20000. Okay, that's pretty good. Pretty good. So now we know that's not there. It's not crashing there. So where is it crashing? Let's do something like log.info current range is sure any, and we do current range. Okay, so we do crash before we get to our current range. So let's see where we are crashing. So hold on, register range, VMM, we've initialized that. We've created all the nice lists. Okay. Oh, okay. So let me just do something like, log.info, registering range with type. What should this be? String, and this would be type. Get rid of that. And then let's do log.info registering free range. Of course, we obviously need to add that. So let's just do log.info check-in range any, and this would need to be range. Okay, we'll get there. Invite format, of course. Invite format. This needs to be tag name of type. All right. So we do crash fairly early. Are we even getting to registering ranges? So I'll info try to register ranges. Let's see here. Okay, so we actually are crashing somewhere here. Just kind of weird. After init, No, so we do initialize correctly, but what is the matter here? Is it accessing kernel N that's causing the problem? Right, hold on. Let me do something like kernel and it should not be the problem though. So X, let's add that and do kernel N. So we should already have the info about where the kernel ends from our bootloader. Oh, okay, so now, okay, so accessing kernel end is the problem. Kernel end found at there, so we should have this as our value. Right, so let's just do this for now. Okay. Huh. So 16,000, and here we are getting told that it's 15,000. So, what is going on? What is going on indeed? So this one is 4K aligned, and it should be 4K. And all right, let me just go ahead and go here to VM read elf. Let's just get all, and let's get kernel.64, I think, .elf. And I need kernel end, and that's here. Okay. So that means that whatever we've computed in our bootloader was wrong. We still need one more page in there. Oh, right. Actually, hold on. Did I mess things up by... So where is our kernel and? Kernel and is the last address. Okay, fine. So we have messed this up because kernel and points to the start at this moment here. We have put in it the start of the last page we've mapped. So it means that we should actually move it forward by one whole page. And that should fix this issue. Let's see. Okay, so here we have the correct kernel and this one here also does have the correct kernel and. Okay, so that means that now we just have the other problem, which is so where were we? We were here. This symbol here is the actual address, or rather, it's the actual value of our symbol. Whereas we expected it to be the address of our symbol. So this one here needs to be that. Wherever there's a kernel, and we need to use the address of that. Oh, right. Okay. So const u64 and compile int, of course. So this one needs to be int from pointer of that. and I believe we are going to need to do a few more things. So const can this be just created here? So const kernel and is int from pointer of kernel end. Okay, and does that now mean that I can just replace this by kernel and unable to evaluate comp time expression? Okay, so the addresses are resolved at link time, not comp time, so it's actually fine. Right, let's see. Hopefully no crashes this time, and that's actually good. Register in range with type, quick map PTE, and a free range, and then we get a current range is null. But we are not printing our ranges though. For some reason this is not doing anything. Let's add something. Is it because this is debug? Let's do something here. Free virtual ranges. Oops, there we go. Right. So we are not printing any range. So the registration is not working correctly, but that's fine because we are at least getting there. Okay. Right. So current range is null. So that means that we should actually go into the else. So let's check that we are actually getting into the else. No current range. Okay, so we do get into the no current range. That should be fine. So now why are we not able to append that to this? Let's do something like that. Let's just get rid of this here, I think. We don't really need that anymore. Okay. Okay, so now we do have a range that goes from first page to, well, that has 10 pages in size. And null, what is null? So that's under range. It's under range, so vert mrange. What is null? Type, oh, okay, so type is null, that's fine. Type is null, so that's fine. So if type, let's go, type, oops, so if self.type, type, we do this thing here, else we do that with free, and that would be type, tag name of type. That would be nice, and that means that this should be a string. unused argument, of course. We need to remove this now. And this should solve all our problems. Cool. So now that we have this problem solved, let's try to move forward with our implementation here. So we have this range added. So now let's try to add register range. Let's add a range that starts at 3000 and has a length of let's go for 5 pages. And that's just that. So basically this range here should be within this first range. Then let's add another range that starts at 9000 and has a length of 0x. Let's go for 19000. And I'll just go here and do something like this. Right, let's see where we go from there. Okay, so we have a range that goes from 1000 to 8000. And then for some reason we have a range that goes from 9000 to the end. Okay, so we did not handle this correctly then. So we are checking range. This current range is this. And here for this range here, we did not find a current range. Why is that? Okay, so now we know where the problem is. The problem is around here. So if we try to do vmm.print self. Oh, we don't have a self. Lol. So how do we go about this? We can actually yeah, so we cannot print pages here, but we know how this should behave because this goes from so if we remove this should go from 1000 to 9000, so that has a basically a start at 1000 and an end at 0x A000. And this one here is within that range, so that should not change anything, so it should have the same range. This one here basically starts at pretty much near the end of that range and goes further, so that maybe should be, or not maybe, that should be actually merged into the first range here. But we did not see that. So why is that the case? Maybe the way we are checking the ranges is wrong for some reason. So we should have that the start of that range is larger than the start of the current range, and it's and lower than or equal to that range. So we should actually be in this situation here, which is weird. Start is, let's just do something like this would be start and end. Right, so here we are trying to register this one here. It goes from 1000 to that, so that's fine. Then we are registering this one here. That's pretty much within this one, so that should be still fine. Okay, then we try to register the third one, which is also still within that range, but it's not going correctly. Just going to try to do this for now. Just look at the first two ranges, just make sure that those two behave correctly. Right, so let's see here. What is the final range? And the final range is actually wrong. Why is it wrong though? Are we taking the min of the ends? No. Current start plus length. Start plus... Okay, so this might be the problem. This might be the problem. So let's set this to current and... Okay, so that should solve it. Right, so yeah, they are correctly merged now. And now if we go here, we can just do this, rebuild that, and check with a range that basically overlaps, but is not contained within. Okay, so that looks pretty good. Yes, that looks pretty good. So that means that now if I add one more range, and this range here will start from 0x B0000, so trying to go a bit further away from where we are currently, and I'll add about let's go for a few pages. Let's see. So here we expect a new range to be created, and let's see. So B0. Right, that's pretty good. So now let's try something else. Let's try something that's a bit harder. Let's try to bridge the gap between the two. Let's try to go from 22,000 to whatever that address is. So let's go from 22,000 to so we want to reach B0 that. So I guess I'm just going to do something like this. Let's see. The expectation here is that we are going to reach... So we go now from there to there, which is okay, I think. Just trying to go back to the last results we had. So those are here. So this range here got merged with the previous range. Okay. Oh, right. Okay. So there's one small issue with what we are trying to do here, is we have never actually breaked out of this loop. So we keep going until we find the last range that matches, which is probably not what we want to do. We just want to find the first one. And here we should have the first one being extended to meet the second one. So now let's check if we do a few more things. So all of these cases now should be handled correctly. The only case that's not handled correctly is when so what we have done here, we've extended this to touch this range, but we have no mechanism to merge the two. So for now, they are just going to stay as two separate ranges. But we could add something that basically checks if we have contiguous ranges and merge them afterwards. So maybe here at the end we can add something that's check for contiguous ranges, or we can just basically add logic here, redo a loop to make sure that we have no contiguous ranges or no unmerged contiguous ranges. Right, so this one here should be okay for the free ranges. For the free ranges. Now, if we go to the reserved ranges, here we have one more step, which is I think actually we should just get this here, except that this would need to have an additional condition on it. So let's actually do something like this, and let's go here and add one more, and this should have type should be equal to so current range.type. I believe that's, or rather, hold on, current range.type with an E, because I believe that's what it is. So with this, now we have our current range, and we should probably do the same logic as we did here. So maybe this would need to go to the same, to some function. For now, let's just copy it, and we'll make changes if needed. And I think we should have the same logic here, except that this one here would need to be, okay, so this one here needs to be reserved ranges, and this here needs to be reserved ranges. Okay, so we are almost there. Error type memory does not support virtual field, or rather, does not support field access. And why is that? It's nullable. Okay. So this one here, we did not. Oh, right. It's not current range. It's just range.type. And that should be okay. Right. We already have two ranges, two reserved ranges we get added there. So let's actually make a function to print those so reserved ranges. And that should be just here, reserved ranges. Reserved virtual ranges, and that the rest should be okay. And that means that now if we go here and we just duplicate this and do that, it should be okay. Right, so reserved ranges, we have the first one Why do all of them have 3? Oh, we've never set them actually. We've never set the range. So this should be here. Type is type. All right. Okay, so quick map PTE. That looks good. I'm not sure. Oh, yeah, no, that's fine. That's fine. Okay, that's actually pretty nice. This is 1 page, and this is a few pages. We have 8 CPUs, so that goes to... Oh, we have the size here, so yeah, that's correct. That is correct. Right, so now let's try a few other things. Let's try to actually create a few ranges here. So let's go try vm.register range. Let's go for, if I go to my linker script, let's get frame buffer. Oops. Let's get the frame buffer. So this one starts here and has a size of, what should be the size of our frame buffer? I actually have no idea. So let's for now do 64 megs. Yeah, sure. Let's go for 64 megs. So, oops, 24, 24. That's megs. And the arguments, the type will be frame buffer. Yeah, sure. Let's actually write frame buffer just so that we know. And we should have type somewhere here. There we go. So frame buffer. And that's looking good. So let's also do, what was the other thing we had in our thing here? Boot info and env map. Not really sure we care about that. For the rest of the reserved ranges, I'm actually going to need to think about what should go where in our kernel's virtual page map. But for now, let's just keep this in here and try to make it as simple as possible to use. Right, so here we want to reserve a range. So if the range exists in the free ranges, then we should get that or carve out that range from the reserved ranges, from the free ranges, put it into the reserved ones. Otherwise, we just add it. So basically what this means is that we will always add it to the reserved range. So we are just going to basically copy whatever we've done here. Well, not exactly this, but it should be somewhere over here. Yeah, actually this needs to be renamed, doesn't it? Reserved. Yeah. Right, so let's get this. Where were we? We were somewhere here. So that should go there. Pretty much always. Type and all. And now we just need to basically var iter is self.free ranges, self.vmm.free ranges.iter, and while iter what did we call that? Item. And so while we have an item, we should actually take that as a pointer to something. Okay. So while we do that, we should go ahead and get the range, I think. Yeah, so that's item.range. And from that range, we are going to, actually, we probably need to get the range as a pointer, and the item is already a pointer, so that should be fine. Now, actually, never mind. This needs that. Okay, so now we have range. We need to check if, actually we have all the logic we need somewhere up here. So we are checking in the free range. So this is the logic we need, actually. We basically need to find the first range that contains or overlaps with the reserved range we want and carve that out. And actually, we'd like to find all of them. Let's think about this. No. So if we make sure that our ranges are or our contiguous ranges are merged every single time, we are sure that this range here will fall within one single range. So I'm pretty sure about that. Right, so let's compute the and. So and is start plus length. And here we don't need this. Actually, we just need to make sure that we remove the range from the free range. So if it's at the start, so there are three cases actually. So either we have the range starting at the start, and that means that we just need to move S1, so the start of the first range we have, forwards. The other way this could happen is that we have this range overlapping at the end. So that means that we need to move E1 backwards. And the third case, which is the most obnoxious, I think, is if we have S1, S2, E2, and E1. That means that we need to split the range into S1, S2, and then that empty space, and then E2, E1. Yeah, so this one here is the hardest, but these two here should be fairly easy. Now, this one here means that if we take a look at how this can happen, this only happens if, so if we go back to our diff thing, so this one here would need to be, so range start minus start, and this would be and diff, so this would be range and minus and. So in this case we are so S1 minus S2, that would be start diff would need to be less than 0, and so E1 minus E2 and diff would need to be above 0 basically. And in this case here, we are going to need to do a few things, which is resize the existing range to S1, S2 and create a new range for E2, E1, basically. Yeah. Yeah, okay. So that's that. Let's start by resizing, I think. So that means that range.start, or rather range.length, would need to be shrunk. Or rather, let's just set it directly. This would need to become the difference, the start diff, or minus, I guess let's recompute it. So start minus range start. Yeah. And then we need to actually const free range item is we'll try self dot allog dot create a vert mem range item list or list item, and then we are going to set free range item deref that and say to so range would be start is bitcast of so what would this start be? So this would be end, right? And the length of that would be range and minus and. Of course, the type would be null. Right, and then we are going to need to do this vmm dot free ranges dot insert after, and it takes the node. So this node here would be range, and the new node would be free range item. Actually, the node is not range. The node would be, what did we call that item? This way we are sure to keep the order of things, I believe. So, right, so that's for that case. For the other cases, we should actually have, so for this case here, we should have S2 be there, and for this case here, we should have E2 be actually somewhere here. Hold on a second. No, this should be E2 here. Yeah. We should have something like S2, E2, and this one here would be something like this. So this means we move S1 to S2, and this means we move E1 to S2. Right. And I think that this can become an if-else. So if we have just one of those two conditions, so if we have start diff less or equal to 0, so what is start diff? Start diff is S1 minus S2. So that means that we have this case here, S2 minus yeah, so S1 minus S2. If that's negative, then we must be in this case here. So this one is S1 is above S2, right? and this one here is S1 is below S2. Right. So if start diff is negative, then that means that we have we are in this case here. Right, and that's in this case we move E1 towards S2, if that makes sense. So that means that range.length would need to become, or rather it needs to be shrunk by the difference between range and the start. And else if start diff is positive, then that means that the range.start would need to move forwards by, so how much does that move the start? It needs to move forward by the difference between by start diff, I guess. Yeah. And the range.length this time would need to move backwards by start diff. Yeah, I'm gonna need to test that, but for now it should do the trick. So we need to allocate a range that might or might not be typed, or might not be reserved. So I guess we could go for const list equals undefined for now, and we can do if args.type, capture that as type, then we do something like list is well, actually it's kind of useless because we are still going to need to use type, so let's just define list inside here. Right, so let's go for var iter is self dot vmm dot reserved ranges dot iter, and while iter dot next, and get that as item, as we've always been doing, and we are going to get range from that item, so item dot range. And now we are going to check if we, so hold on, let me just get rid of those. So we need to check if we are within that range. So if, or rather not within that range, but if that range has enough length to basically handle our location. So here we actually should split this into two cases. Else if range.length is strictly larger than length, that makes it easier to work with this. So here in this case we just basically return range, so return so let me think. We need to return range, but before we do, we need to remove yeah, so self dot vmm dot reserved ranges dot remove item from there, and probably defer self dot alloc, or rather self dot vmm dot alloc dot destroy of item. And then we copy out the range from item and we move that, return that. Obviously here we have a type, so we should also do the check on type. So if range.type is different from type, then we continue to check the search. Right, otherwise we have length that's larger than length, and here it should be fairly easy. We just need to create new range, or yeah, so for now let's just go ahead and create that. And this would be a vert_mem range that has a start of range dot start and a length of obviously we need to do this of length and a type of type. Right, so that's the range. Now we need to check that our range here, which we are going to take as a pointer, we can modify. Actually, let's also do something like this. We need to move the start forwards by length and move the length subtract length from length, and then we return new range. Okay, so that's pretty much it for this case. The other case is pretty much the same, except we work on the other list instead. So I think here I could just do this and do reserved goes to 3. And that should work. And of course we'll have a type, so that should be fine. And this one here would need to also disappear. Okay, so that's okay for allocation. To free it, we are going to need to do the opposite of what we just did, but same as with the physical memory, I'm going to skip that for now.